In this example, we'll be learning about the commutative characteristics of vectors. It is important to note that in example 2, Victor's total displacement, the resultant, was independent of the order in which the vectors A, B, and C, and D were added. Thus, we can add them in any order and still get the same solution for Victor's total displacement. Let's consider an alternative story where Victor walks the same vectors, just in a different order. The story goes like this. It's a stormy day in Scholar City, and Victor plans on meeting his friend Sheldon at the Bean and Gone Cafe. Starting from his house, Victor walks 1 block east. He avoids walking through Vector Park as he assumes that it will be muddy. This vector is 35 meters in length and in the east direction. This is identical to vector B in the example number 2, therefore we will continue to refer to it as vector B. After walking 1 block, he notices an alleyway offering a diagonal pathway to the coffee shop. Victor decides to take the shortcut as it is beginning to rain harder. This vector is 48 meters in length and in a direction of 45 degrees south of east, which is equivalent to southeast. This is the same as vector A in example 2, thus we'll continue to refer to this vector as vector A. He meets Sheldon and they both order a cup of coffee. The coffee at the shop is horrible, so Victor and Sheldon decide to head back to Sheldon's house to make a quality cup of coffee. They first head 1 block west and arrive at the street on which Sheldon lives. This vector is 35 meters in length and in the west direction. This is equivalent to vector D in example number 2, thus we'll continue to refer to this vector as vector D. They then head 3 blocks south until they reach Sheldon's house. This vector is 102 meters in length and in the south direction. This vector is equivalent to vector C in the original story, thus we'll continue to refer to it as vector C. Victor and Sheldon then enter Sheldon's house and enjoy a quality cup of coffee, of their favorite cup of coffee. Using a ruler and protractor, we will draw an arrow from the tail of our first vector to the head of our last vector. This vector has a magnitude of 139 meters and is in the direction of 75 degrees south of east. The point to remember, in the first story, the order of displacements was A, B, C, and D, while in the alternative story, the order of displacements was B, A, D, C. The total displacement, or the resultant, however, was unchanged. This characteristic, adding vectors in any order and achieving the same resultant, is true for all cases. Operations that have this characteristic are described as being commutative. Thus, we describe vector addition as being commutative.